All right, here we go. This is the second part of section 3 in chapter 4, and we're doing more properties of these powers. But today specifically, we're going to do powers of powers. So let me get the screen set up for you well here so you can actually see what's going on. And let you get that heading up on your notes. Make sure it says powers of powers. That kind of makes you sound like it's something superhero related, doesn't it? Oh, cool. All right, here is today's learning target. All right, it's going to look very similar to yesterday because it's the same thing in the sense that we're going to evaluate expressions, whether they're just numbers, meaning numerical expressions, or if they also have variables, so that'd be algebraic expressions, okay, using properties of exponents. Today, however, your properties are going to focus in on powers of powers. Now, yesterday we were just focusing on whether you're multiplying things with the same base, dividing things that have the same base, and seeing the relationship that happened there. Today we're going to get powers of powers. So it's kind of like we're stacking it all up. Ready? Look for a pattern. Okay? Always have your eyes attuned to look for a pattern. So let's look at this first example. 5 to the 4th power to the 2nd power. Okay? A power of a power. Well, let's start with the outside and work our way in. Mainly because here's the deal. Normally, if I gave you this expression and I said evaluate it, you would start with order of operations, which is, please excuse my dear Aunt Sally, and you'd say parentheses, oh, I need to calculate 5 to the 4th power first, and you get something like 625, and then you need to square that, which is going to be this ginormous number. Okay. Today, though, however, I'm not interested in having you evaluate the number and getting this giant, huge power of a number. I want you to look at the relationship between the base and the exponents and leave your answer in exponential form. So on this one, let's first of all see what this means. This means 5 to the 4th power times itself. And now, ding, all of a sudden, it looks just like the problems we were doing yesterday. Oh, 5 times 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 5. I don't want to write all that out because math people, we are efficient. And if I don't have to write 5 eighths strung out in a row being multiplied, I can write it this way. That's the way you want to go. All right, let's look at another one. 3 to the 3rd power to the 4th power. Think about what this means working from the outside in. That means you're taking whatever's wrapped inside these parentheses, this quantity, and you're going to string it along, multiplied as a factor 4 times. So this means 3 cubed, 3 cubed, 3 cubed, 3 cubed. That gives me 4 of them. Now, if I wanted to be super picky and expand all of this out, I'd write 3 times 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 3. But yesterday, we simplified problems like this, and you saw what this property is when you have the same base, because it's all about that base, about that. Sorry, you're sick of that song, so am I. All right, this is 3 to the 12th power. That is a very, very large number. I don't need you to use your calculator to tell me what it is. I'm simply after you just leaving it in exponential form, okay? Cool. How about this guy? Anything, this entire quantity to the 2nd power means 4 to the 8th times 4 to the 8th. That means you get 4 to the 16th power. Even if we used variables, so if I had something like y to the 7th power to the 3rd power, this just simply means take the quantity that's inside there and use it as a factor 3 times, multiplying by itself. Y to the 7th, y to the 7th, y to the 7th. There is no way I am writing out all of those y's because yesterday we saw that our property said, hey, just add your exponents together. There you go. All right, you've seen 4 examples. Do you see a pattern that's going to lead to us writing a rule? Let's go back and look at them. 5 to the 4th to the 2nd. I'm going to change colors so I can kind of emphasize this for you here. 4, 2, 8. 3, 4, 12. 8, 2, 16. 7, 3, 21. See it? Nice. So when you have a power of a power, okay, so to raise, so this is your rule, and write this down. To raise a power to a power, keep the base, okay, so on all of those, whether we had a 4 or the letter Y or whatever, keep the base and multiply the exponents. It's as simple as that. Seriously. It really, really is. So if I move on and I say, well, what if you have negative exponents? Okay, well, let's look at one with a negative exponent. If I have 13 to the negative 4 power and I am squaring it, that means I take 13 to the negative 4 times 13 to the negative 4. Now, my rule from yesterday said add the exponents. Negative 4 plus negative 4 is negative 8. Okay, or oftentimes we don't like looking at negative exponents, and we don't necessarily like leaving our answers this way. So maybe you prefer writing it this way, that this means 1 over 13 to the positive 4 power, 1 over 13 to the positive 4 power, which would be 1 over 13 to the positive 8 power. Okay, for today's purposes, I'm going to say either way that you write that, I'll say is okay. I'm really after you recognizing this pattern. Negative 4 times 2 is negative 8. Okay, there's nothing wrong with writing it out. Don't get me wrong. But if you can see the pattern, it simply will make your work that much more efficient. M to the squared to the 19th power. All right, hold on here. Good gracious, I do not want to write m squared, m squared, m squared, m squared, m squared 19 times. Oh, I really swear I have better things to do, and I get it. I get the pattern. Multiply your exponents. So take 2 times 19. If you can do it in your head, that's 38. Boom. That's a whole lot of multiplying, which is why I'm very glad we've recognized the pattern. All right, now this one, it's another negative exponent, but that's okay. You still do the same property. Keep the base, that's 7. 3 times negative 4 is negative 12. For today's purposes, you could leave your answer that way. Usually, we don't like to leave our answers with a negative exponent. It's almost like leaving a fraction that's not in simplest form yet. So if you left the answer as 3/6, I would say, oh, it's best to write that as 1/2. Same thing here, 7 to the negative 12 power. It's a little cleaner, nicer, neater to write it as 1 over 7 to the positive 12 power. Awesome. Look at this guy. Oof. This is a big one. Okay, 9 is your base. That's this number. Power to a power, so multiply the exponents. Again, yeah, technically that's okay, but I prefer writing it with a positive exponent, which means put it in the denominator of your fraction. Oh, what about this guy? Okay, I kind of had him end up being really way, way down here at the bottom. 10 to the 4th power to the 0 power. This one I couldn't even expand out because what on earth does this mean? This is when it's good to have this property built into your head. This means take 10 and multiply your exponents. Well, what does this mean? This would be 10 to the 0 power. And really, what's that? Yay. How simple is that?